Assalamu alaikum. I am Dr. Muhammad Shoaib, and today we are going to study classification of polymers. What are polymers? As the name shows, it is composed of two parts: poly, which is derived from the Greek word polos, meaning many or much, and meros, meaning part. It refers to the macromolecule composed of multiple repeating units and is characterized by a relative high molecular mass that is usually more than 10,000 AMU. And these repeating units are called as monomers. Here we will see some definitions. What are monomers? Monomers are the small molecules which can undergo polymerization. That is, these are the constitutional units of polymers. A dimer. When two monomers join, a dimer is formed. And oligomer. Oligomer is a structure which consists of few monomer units. Usually, its molecular mass is less than 10,000. And if the molecular mass is greater than 10,000, it is called as polymer. Macromolecules. Usually the macromolecules are the individual molecules of high molecular weight. Classification of polymers. We can classify a polymer on the number of bases. Here are some types of polymers. The classification of polymers. The polymers can be classified on the basis of their origin or source into the natural, synthetic, or semi-synthetic polymers, or the polymers can be classified on the basis of nature of bond, that is ionic or covalent polymers, and on the basis of arrangement of polymeric chains. Polymers are linear, cross-linked, and branched polymers. On the basis of physical properties or thermal properties or intermolecular forces, these are classified into elastomers, thermoplastics, thermosetting polymers, and fibers. On the type of repeating units, that is type of monomers, homopolymers, and copolymers. On the basis of stereochemistry or crystallinity, these are classified into isotactic, syndiotactic, and atactic polymers. And another one classification is based on the functional group, although it is less commonly used. On the number 8 is the classification based upon the mode of polymerization or the polymerization process. It is of two types: chain growth or addition polymerization, and the second one is step growth or condensation polymerization. Addition polymerization is further divided into three types on the basis of intermediate form, that is radical, cationic, and anionic polymerization. On the number 9 is the classification based upon the polymerization technique. The chain growth polymerizations are of four types: bulk, solution, suspension, and emulsion polymerization. And step growth or condensation polymerization is divided into two types, that is melt or solution polymerization. We will see all these classification very briefly here. First is on the basis of region or source. Natural polymers, as the name shows, they occur in nature and exist in natural sources like animals and plants. Protein is a natural polymer which is found in humans and animals and sometimes in plants too. Cellulose and starch are of plant's origin, and rubber, which is harvested from the latex of a tropical plant, it is also of plant origin. These are the natural polymers. But the natural polymers sometimes do not meet our requirements. So there is another class of polymer called as synthetic polymers, which is very widely used. These are artificially synthesized in lab or on a commercial scale in industries. For example, polyethylene or nylon or polyurethane, etc. And sometimes there is a hybrid of natural and synthetic polymers, which can be called as semi-synthetic polymers. Usually we obtain our required properties by modification in natural polymers by the use of controlled chemical reactions. These are of commercial importance. For example, vulcanized rubber, which is of natural origin, it is cross-linked by the use of sulfur. The modification is done artificially. So it is an example of semi-synthetic polymers. Another one is cellulose acetate. That is, cellulose is modified. It is called as rayon. On the basis of nature of bond, that is ionic and covalent. Although we have focused on organic polymers, but there are some inorganic polymers too. Organic polymers usually consist of backbone chain of carbon and hydrogen, and there are some heteroatoms such as oxygen, nitrogen, and sulfur, which are frequently present in these type of polymers. Examples are plastic elastomers, films, fibers, which are used in many areas of life. The advantages are that is easy processability, they have high strength and low density, but the disadvantages of many organic polymers is that they are not temperature resistant and cannot be used in high temperature application. At very high and very low temperature they are deteriorated, and most of them are easily degraded by oxygen, ozone, or high energy radiation, that is, they are oxidized. So there are some inorganic polymers which consist of inorganic main chains with organic or inorganic side group or moieties. Examples are borazine polymer, phosphazine, polysilane, etc. Next is classification based on the arrangement of polymeric chains. As the name shows, linear polymers are those in which polymeric chains are linearly arranged. Monomers are linked together to form long straight chains. These polymers show close packing, so they have very high melting point and high density. Example is PVC, polyvinyl chloride, and high density polyethylene. Branch polymers, when some branches originate from the main polymer chains, the resultant polymers are called as branch chain polymers. The disadvantage is that these polymers are not closely packed together, so they have low density and low melting point. A common example is low density polyethylene used in making plastic bags, which have very low strength. And the third one is cross-linked or network polymers, in which monomers are linked to form the polymer chains, which are arranged in three-dimensional network. Polymer chains are cross-linked with each other, or these chains are connected with each other through strong covalent bonds. Usually these are the monomers in these type of polymers are bifunctional and trifunctional. These polymers have very high strength. These are hard and that's why these are brittle. For example, bakelite and melamine. Here is the pictorial representation of linear branched and cross-linked polymers, and these structural characteristics are very closely related to the properties of these polymers. And this classification is based upon the intermolecular forces, and as the intermolecular forces strongly affects the physical properties, so this classification can also be called as a classification based upon the physical properties such as temperature or the thermal properties. The first one is elastomers. As the name shows, they are elastic in nature and are rubber-like solid. A common example is a rubber band. Here the polymer chains are held by the weak intermolecular forces, which allows them to be stretched when a force is applied. And when the force is removed, these cross links between the chains helps to regain the original shape of these elastomers. However, these polymers only regain their original shape up to a certain limit, which we all have studied, that is called as Hooke's law. If they obey Hooke's law, then after removing stress, strain is also removed. A common example is tires of automobiles, which is made up of vulcanized rubber and cross-linked with sulfur. And another example is polyurethane elastomer, which is of tremendous importance in industry, and Thousands of research papers are being published on the polyurethane elastomers. Second is thermoplastics. As the name shows, these are plastic in nature. The term plastic implies that it can be D-shaped when a force is applied. These polymers consist of long chains with intermolecular forces which holds these chains together. They are softened on heating, and when the heat is removed and they are cooled, a hard mass is produced. There is no any crosslink in these polymers, and they can be easily molded into any shape by using heat which softens them. Common examples of polystyrene and PVC pipes. Next is thermosetting. Thermo mean heat, as we all know, and setting mean the conversion of any material into a hard mass. These polymers are semi-fluid in nature and have low molecular masses. When they are heated, the crosslinks between the chains starts and they become hard. So when the heat is removed, they are not softened again. That's why they are called as thermosetting, that they are hardened by the application of heat. Heat brings about the changes in their three-dimensional structure, and these changes or the reactions are irreversible in nature. A common example is bakelite. Fourth type of these polymer is fibers. These are thread-like polymers and they are easily woven. There are intermolecular forces between these threads or chains, such as hydrogen bonding, dipole-dipole forces. These are less elastic and high tensile strength. That is, a high stress can be applied before any strain is produced. They have sharp and high melting point. Nylon 66 is very common example. On the basis of types of repeating units or monomers, there are two classifications. Homopolymers, as the name shows, these polymers consist of only one type of monomers. The common example is polyethylene. As the diagram shows that there are only one type of monomers. Copolymers further classified into four types: alternating copolymers, such as nylon, as the diagram shows that the two type of monomers comes in alternate positions. Second is block copolymer. As the diagram shows, first one monomer is joined to form a block, and then the second monomer is joined, and in such a way blocks of two different monomers are joined to form block copolymer. Third is random copolymer. As the name shows that there is no any arrangement. The two monomers or more than two monomers are randomly arranged. Example is resins formed from styrene and acrylic or methacrylic acid derivatives. Next is graft copolymers, that is a backbone or chain consists of one type of monomers and the grafting or branching consists of second type of monomers. On the basis of stereochemistry, atactic polymers are those where the side chain is arranged randomly along the backbone chain. Usually these are formed by free radical. An example is PVC polyvinyl chloride. Here we can see that there is no arrangement. Isotactic polymers are those in which chain is arranged on one side of the backbone. Here are the chains are arranged on one side of the backbone chain. An example is polypropylene formed by Ziegler-Natta catalyst. Third is syntactic or syntactic polymers, where the side chains are arranged alternatively on both sides of the backbone. For example, polystyrene made by metallocene catalysis polymerization, and second is trans 1,4-polyisoprene. It is also called as gutta-percha polymers. This classification is less commonly used. It is based upon the functional group present in a monomer or the polymer. It is a polyester. If an ester functional group is present, polyimide, basically it is amide, polyether, and polycaprolactam, polyamide. These are the polyamides, polyolefins, and polycarbonates, etc. On the mode of polymerization or the polymerization process, addition polymers are chain growth polymers, in which the polymers are formed by the repeated addition of monomers. Here the monomers are usually with a double or triple bonds. As the name shows that there is only addition or chain growth, so there is no elimination of small molecules like water or ammonia or HCl. Here the empirical formula of the monomers and the molecular formula, here the empirical formula of the polymers and the empirical formula of monomers are the molecular formula of monomers, both are same. Ethene having formula CH2CH2 and the polyethylene also have the same formula. It is further classified into three types. First is the anionic polymerization. If the intermediate chain or intermediate formed is anion, it is cationic polymerization if the intermediate is cation, and it is a free radical polymerization if the intermediate is free radical. Second type is condensation polymerization or step growth polymerization. These type of polymers are formed by the combination of monomers which have bifunctional or trifunctional in nature. They condense together with the elimination of small molecules such as water, ammonia, or HCl. A common example is polymerization of adipic acid and hexamethylene diamine. It produces a polyamide called as nylon 6,6. Another example is the polyester formation from a diol and a diacid. And at last, on the basis of polymerization techniques. Bulk polymerization or mass polymerization. It is carried out by adding a soluble initiator to the pure monomer in liquid state, and this reaction is initiated by heat or radiation, which results in a viscous mixture of the polymer. The reaction is highly exothermic, and the disadvantage is that a range of molecular masses are produced which are usually low molecular mass. Examples are polystyrene and polyvinyl chloride. To overcome the problem of heat or exothermic reaction in the bulk polymerization, a solution polymerization is carried out in the presence of a suitable solvent. This solvent lowers the heat and it also lowers the viscosity. Thus heat is transferred. The polyvinyl alcohol and polybutadiene etc. are obtained by this process. Suspension or pearl polymerization or bead polymerization. This technique is employed if the monomer is insoluble in water. So the suspended droplets are polymerized. Here the most of the process is mechanical process. Monomer is mechanically dispersed. An example is polyvinyl acetate. Another is emulsion polymerization. The difference between emulsion and suspension polymerization is that emulsion polymerization is necessarily a chemical reaction. Here a water-soluble initiator, a chemical emulsifier, and the third component is the monomer, which is slightly soluble or completely insoluble. This type of polymerization is used for the elastomers and plastic formation. And this was all about the classification of polymers. If you have any question, you can drop it in the comment section. Further detail of all these topics you will study in our upcoming lectures. Thank you.